Yeah, so today I wanted to spend some time with you guys to present some of the ideas we've been developing around this collaborative open data exchanges, some of the open questions around it, some of the more formal aspects of it that could be worth discussing. And yeah, so I'm gonna dive in.
Prego. Aliciana, non sto cacchi di pe.
See my screen?
Andre, I think you're unmuted.
Can you all see my screen?
Yeah, we can see.
Yeah, great. So, okay, things I want to go over. So we have this idea of building this collaborative open data exchange, which if you remember a little bit, this is kind of a global view around these different layers of abstractions that are important to keep in mind just to get situated what we're talking about. At the very top, you have end users. These could be preprint platforms, journals, any type of like DNS domain, essentially controlled by an entity. One level down, you have applications. This is, this idea of a host of like user-facing applications, right? Not AI-facing applications. Those are called services, but user-facing applications, such as like the DeSci node interface is an example of such an application. You have services that are associated with the protocol, things like PIDs, right? Deterministically resolvable PIDs that Andre and people in my team are actually working on. We have, and then there's a whole host of interoperability services that need to be built in order to form connection point with the existing infrastructure, right? Because we cannot really build in a vacuum. We need to have as many cross connection points as possible. Then there's this abstraction layer, which we call like this collaborative open data exchange, or CODEX for short, which is essentially a series of abstractions. These are entities with rules on how they combine and connect, and they're optimized for querying efficiency and for a number of parameters as well. And essentially, these are like these data entities. You could think about that as a vast like open data lake in which you're growing all sorts of trees and mangroves, right, which are these Merkle DAGs, on which you have curation activity, which are essentially expressed as like this open annotation and attestation system around leaves and aspects of these Merkle DAGs that are on this distributed and open state database, right? And essentially the shape of these objects that live in this open data lake are what we call these CODEX entities. And at the very lowest level, you have the node operators, right? These are network participants that run part of the stack in order to power up this open data lake and provide all of the capabilities that it offers, like content delivery, storage, and all of these things. So today I wanted to orient the conversations around some of the efforts I've been, and I'll be putting in more efforts over the New Year's and vacation time around getting kind of like a vision white paper around this. So I wanted to go over some general principles. I want to talk about entities and relationships, and I want to talk about service layer and interoperability. And at the very end, I want to bring up this idea of like a kind of an objective function, quote unquote, but essentially it's like, what should the network strive for, like a data network? And one of the core ideas here in intuitions, and I think it's quite a tractable thing, is essentially how to make data as valuable as possible, right? As a stated goal for this open network. And there's a tech part to it. There's also a curation part, and we can dive into this. So yeah, so prefacing, a lot of this work draws from the efforts around the FAIR community and the FAIR data principles. You can see if you go, for example, on GoFair, this is the type of principles that they have, or criterias, right? They have different ideas that extend beyond FAIR, right? They have this idea of like openness, distribution, no lock-in, which are some essentially core properties that we're elaborating in a technical implementation, right? To realize a vision that is more than just strictly limited to the FAIR data principles, but encompasses this idea of an open state distributed network without any lock-in. So in terms of design goals, and I think this is also a really interesting place for you guys to give us some feedback. So we outlined a couple of following design goals for CODEX, right? So one of them, which is typically not something you see in a spec, but I really insist on it, is things need to be easy. All right, so this is not something you see in a typical spec, right? You will see things that are technically minded, but like it needs to be easy to create, find, and retrieve entities stored on this network in a programmatic and secure fashion, right? So like we need to make to lower the friction to commit entities and retrieve data entities as much as possible, and really strive for that, because that's the basic of the developer experience, right? Providing a good developer experience by making things simple is very important. Versionable and modular, right? So like entities must be updatable and forkable. Versionability must be a first-class property of a research object. These are things, that are typically lacking with the current PID system in science. Recorded provenance for every data commit to the network, and immutable log of who, what, and when must be preserved and made accessible. So this is kind of a precondition for having an open state network, right? You can't have an open state and permissionless network, but you need to have provenance, because if you don't have provenance, then you are essentially navigating blindly across that sea of data. Programmable access. Not all data should or can be openly accessible. The network must allow for both open data and restricted access data. So I think this is we start with open data with a strong emphasis on that, but essentially down the line, providing communities with the tools to regulate access to their data in a self-sovereign fashion is going to be very important. I think especially in the age of closed source AI and related societal debates that we have around this. Permissionless, anyone must be able to create a research object on the network, fork a research object, or enrich a research object with metadata such as machine-readable semantics, social conversation, or attestations, right? It's this idea that anyone can curate these bonsais, right? Or these trees that are growing onto the network. And that's fine, because we have every piece of data on the network is signed. It's digitally signed. So what does that mean? That means we can see the provenance for this open curation, which lets us build systems such as filters, reputation system, and all sorts of things on that network. Open source and decentralized. The network must allow for decentralization to create resiliency, and its underlying code base must be open source to enable collaborative improvement and stewardship. I think there's a separate conversation around open source governance linked to that, but it's just an important point to bring up. Reproducible and verifiable. Protocol must allow for linkage of research artifacts such as code, models, data, and publications into connected entities that enable verifiability, reproducibility, findability, and minimize fragmentation, right? So this is a really hard one, actually, when you think about it, to build out, or like to create, to essentially minimize fragmentation in this graph, because the current scientific record is completely fragmented, right? There's very few links between artifacts that if you query Crossref or DataCite's API, you see that a lot of this is lacking. The idea is, how can we essentially create a system that really simplifies this linking to reduce fragmentation, and ultimately to allow for things that belong together, that have shared context, to be together. And plural incentive mechanisms, right? So this is this idea that we have to allow for a plurality of independent incentive layers that can be ruled by these communities. Over time and through trial and error, this plurality of incentive layers should converge towards a set of incentive-compatible mechanisms, which incentivizes data creators to commit verifiable and valuable data to the network, and curators to create accurate signals of value. That's very important, such that the network becomes more valuable over time for the benefit of all participants, right? So here now we have a lot of assumptions that do not necessarily follow from each other. But I just want to place this as like an overarching principle, this idea that you can have a plurality of communities, have their own incentive systems. They indicate and they signal what they value on the network, right?
Nice.
Yeah.
Ronan has a question here.
Yeah, it's half question, half comment, maybe. These are really interesting, like thinking about them and how they fit in the context of what we're building. I'm wondering about the I guess incentive mechanism. I was trying to figure out where feedback fits in, and it might be sort of on the incentive side, but I feel like it's almost something a little different. Like the feedback is kind of, it feels like it's a really important kind of principle to center here, that information flow, like feedback flows in the network, right? Like even, if it's like a like on a post, or peer review, a rigorous peer review. So yeah, it feels like it kind of lives alongside that plural incentive part, or maybe somewhere else.
So by feedback, you mean, what do you mean exactly? Feedback is like the capacity to enable feedback, or feedback as a set of things, of specific things that you construe as feedback?
for this kind of system, like this kind of decentralized system to evolve and sort of go in valuable directions, there needs to be feedback, just like there needs to be incentives, right? Otherwise, people won't participate in it. But there has to be feedback, because so maybe I'll give a little more context where I'm coming from. Like, for example, the Nano Publications project, it seems like that's one of the things that currently is sort of lacking in it, where you're posting these nano publications, but there's no really good way to see like what people are doing with them or how they're being taken up in more broadly. In science, we have this idea of citations, but that's like a very slow cycle. You get citations.
Oh, I see exactly what you're talking about, and yes, I totally agree with you. It's this idea.
Social media has the rapid feedback. You see replies, you see likes, you see tweets, whatever.
Yeah, essentially you're looking for transparent usage metrics, right? For whatever those are, right? So like a system, or I mean, it doesn't really capture this idea completely, but this idea of like having this real world groundedness in a sense. And yeah, I'm going to briefly touch about this, and I have a lot of questions about this because this is a rabbit hole. And I was thinking a lot about your application, by the way, as a feedback mechanism, right? This idea of like aggregating social activity as a feedback mechanism for how many impressions generated, for example, right? So yeah, I'm totally on board with this. I think we're gonna take a different path, and we'll go back to it.
Cool.
Yeah, okay. So this is one. So if you guys have like ideas, like things that are missing, things that are misconstrued or conceptually unclear, things that are superfluous, right? Because they actually we don't need to have an opinion on this thing because it's perhaps too opinionated, or this thing follows from other things. Or essentially like, think about this. Are these like sufficient and necessary, right? Is there anything not necessary? Is there any, or is it not a sufficient set, right? Let's say we, through some streak of genius and a lot of sweat, we achieve this, right? Can we say it's sufficient and necessary to support, right, such an infrastructure? So as you guys get idea, please like drop some comments. And I'll go to like entities and codex. So entities, so first of all, it's an open schema. So anyone can create new entities, right? There's constraints because if we just let people just create any types of entities, that's fine, but it can lead to fragmentation, poor metadata. It's better to have fewer entities that are well described than a plethora of fragmented schemas, right? So the question is a little bit, how can we create a couple of those like primitives, right, that are valuable schemas that fit a lot of things in there, right? Like how much can we get over the Venn diagram of all possible entities? Like how much can we cover, right, with a minimal set of entities? And so the entities we have now, it's this very loosely defined idea of a research object, right? Which is essentially a file system, right? This file system that it's a container that lets you store arbitrary things and have them connected. We have this so-called concept of attributes, which was previously called claims, but now we're changing this to attributes. Essentially, an attribute is something like the metadata complies with the FAIR principles. The data is openly available. It's just a statement about, it's a statement, essentially, about something, which that something has not been specified yet, right? The moment you connect an attribute with a research object or anything else, it becomes an attestation, right? Because now you're saying the data on this particular research object is open, right? And you're expressing an opinion about the appropriateness of an attribute to describe an object. You have, and attributes have, can be specified in different ways, right? You could think about, for example, the open science framework badges as completely open attributes. Any author, I'm an author, I have open data, I can select open data, I can select open methods, I can self-select these attributes. And I can just signal to the world that according to me, the requirements for these attributes are met, right? So this is a case of like an open attribute. Then you might have closed attribute, like, published in Nature, or liked by Ronan Tamari, right? It should not be anyone that has the right to express this, such an attribute. And so these attributes, attributes have a consent model, essentially, and the consent model is organized around two axes. One of those axes is the openness versus restricted nature. And the other axis is the reciprocal versus unidirectional nature of it. So for example, if I'm VitaDAO and I funded a research project, and I want to claim and I want to create an attestation that says VitaDAO funded this project, that makes sense for it to be both a restricted attribute and also a reciprocal attribute, because the person on the other end receiving the attribute should be able to consent to clearly see, yes, in fact, it was funded by VitaDAO. And they are not, claiming things that are not true with regards to the things I've done. And then we have annotations, which is a very broad category. Essentially, you could think of annotations as a little bit the glue that connects things together. And it's there to support conversations like microblogging, like tweets, like highlights on a paper with a comment. It's also there to support semantic payloads, right? Things that would be associated with metadata, for example. The ability to say, hey, this particular data set has, this, corresponds to this type of ontology control vocabularies, or here's a set of embeddings that encode the embedding space of this abstract, for example, right? So like it's this loosely defined, kind of completely open tags that you can attach to the branches of these tags, essentially. So yeah, so like again, same as the previous one. If you guys have any ideas, just write them down there, and then I'm gonna, as soon as I'm finished with my monologue, we'll dive into the responses and the ideas. Okay, then we have services, PIDs, and APIs. I'm not going to dive too deep into this, but this is the idea that it's much too hard nowadays to build a scientific application. It's even harder to build a decentralized one. And one of the things you want to do is provide as many tools and useful services for people who create these applications, right? And so there's, for example, things like the DPID resolver is a very general, very, very universally useful IPFS to HTTP bridge. But there's more to that. There's things like getting a DOI for research object and using the alias function of DPIDs to register that DOI so that we have cross backward compatibility. Things around connecting ORCID IDs so that you can just log in with ORCID and you don't have to deal with any complexity associated with DIDs. Everything is done for you in the background. Same with organizations, making it simple for indexers to ingest the content that's published on the network. So like simplifying the ingestion process by essentially making it compatible with the type of data model that they have on the other end. And this would be, for Web of Science, Scopus, Medgate, Google Scholar, all of those things, right? The idea is like, if there's sufficient valuable data on this network and it's easy enough to index, it will be indexed at the limit because it will be valuable for the scientific record. But we have to make it easy. Like we should not like expect that these indexers are going to go out of their way to do this, especially not early. And then, of course, like this idea of like connecting to different platforms, because platforms themselves could be excellent issuers of attestations. For example, bioRxiv, right? They do a pre-check on the preprints they publish, and having an attestations like, from bioRxiv or like, open on bioRxiv is a way to say that it has passed a certain numbers of checks and verification. And so the idea is that any type of platform out there could, use these types of connectors in order to programmatically retrieve data from CODEX in a way that's compatible with their data models, but also push content over to the network in a simple way, right? And this is also a little bit, like the kind of service you're thinking of building, Ronan, would kind of fit in here like really nicely, because it would essentially be like this bridge between scientific content associated with PIDs, right? Typically DOIs, right? With social media activity across network, right? And so that would be one of those layers that multiple applications could use, right, and leverage, and it'd be like, really well suited within as a block there, right? Okay, and yeah, so like I want to talk a little bit about some of the more, let's say, speculative parts about this, things in which I have high uncertainty, and I'm very curious to hear what people think. So one of the questions is like, say you make a box, this box is open, everyone can put stuff in this box, and everyone can use this box. It's a great box, but the box isn't operated freely. There's storage providers, there's people providing infrastructures, network participants, and everything. We can assume that there's a lot of goodwill when it comes to helping out a public good like science, right? So we can assume that the market, the pricing for storage of artifact, all that stuff will be grossly distorted because there will be a lot of pro bono activity. Now, the precondition for pro bono activity is that the entities that are, or not just pro bono, but like even just storing that, is that the entities somehow believe that this content is valuable and that they're doing a service by making it available on the network, right? So how do they know whether content is valuable or not? Well, that's where attestations come in, where you could think of attestations as value signals, right? There's essentially a tree. You don't know if this tree, this DAG is valuable in any way or form. You just know that it weighs 200 gigabytes and you'll store it if it's valuable, but otherwise you won't, right? And how do you know if it's valuable? Well, there's this idea of aggregated signals around attestations that essentially de-risk that piece of data, right? It starts by de-risking it and then it increases its value. And yeah, so like the question is like at the limit, such a network would work great if there's two preconditions that are met, right? One of them is the participants should be posting valuable data in the first place. Now, what is valuable data, right? Here, I'm just saying minimize strategy, right? In a game theoretical sense. What does that mean? That means if I have a piece of data and I have an internal model around how valuable is that data, I should not have a strategy. So that means I should have incentive compatibility with revealing my true underlying belief about the value of this data, right? I should not be trying to trick the system by putting random or completely useless data, whereas my mental model is that this is useless data. If my mental model is it's valuable data and it's useless data, that's a different realm. That means you need an external arbiter. Here, it's really tightly constrained in that sense of like minimizing strategy. Yeah, then there's questions around creating accurate value signals, right? So like having a truthful reporting or like a strategyless addition of data on the network is one thing, but then attestation communities or purveyors of attestations should have, should essentially work towards creating valuable value signals in the first place, right? That's also kind of an important precondition. So the value signals need to be accurate. And if these two conditions are met, beautiful, right? We have a lot of like potential to build on. If they're not, or if they deviate substantially, we have a lot of problems, especially if we implement incentives in the system, right? So then a little bit, where I've been thinking is like, well, what are like types of models around de-risking data? Because I guess this idea of like progressive curation, you could think that there is a kind of this idea of like an ordering of those things, right? We don't need to like, it doesn't need to be strongly opinionated, but perhaps the first question to ask yourself for an attestation community or a storage provider is like, well, is it legally permissible to have this data in the first place on the network, right? So that's kind of like a base test. Or is it like patient data should not be open in the first place, or copyrighted work, right? Then there's another question, which is like, well, is it fair, right? Is it accurately described with appropriate metadata to make it queryable? Or is it going to be impossible to query or impossible to find because the metadata does not describe, even if this is very valuable data, it's useless without metadata to tell you what it is. And then there's, another dimension, which is the more, again, here, I think we were like just going down a gradient of like complexity. And here's things like, is this piece of research connected with artifacts that support verifiability and reproducibility? Is it computationally reproducible? Is the data open? This is at the level where like the OSF badges would fit, in a rough sketch at the level of abstraction. And then you can also imagine having just pure value judgments on things, right? Saying, well, the network benefits more if the entity adding the data actually has an ORCID ID linked to it, right? Meaning it's a researcher, because not all additions on the data, essentially this is a statement saying that there's value in provenance from the network's perspective, right? So it's not about the value of the data itself in a vacuum, it's about the provenance of that data adding value to the network as a whole, right? And I think there's different dimensions here that can be interesting to explore. Yeah, one of the way I've been kind of thinking about it is, so imagine you have these different actors. You might have a community. Does an incentive layer, and its incentive layer is about things that it values, right? For example, computational reproducibility badge really values this. That community. It's a specialist. It really checks that, you know, and it has it creates a valuable curation as a result. You might have a platform now that has an incentive layer that says, well, you know, for example, Research Hub, you know, maybe their stance is like, I really value peer review attestation issued in exchange for Research Hub bounties, right? That's what I value. And that could be, is completely legitimate, and that needs to be incorporated. Or you can imagine a service layer that says, well, that service layer is there to like bridge with LLMs, for example, right? But what it really values is quality metadata, right? So like the AI agents or systems can actually understand what the hell it's about. So it might reward quality metadata that makes the system more digestible by AIs, right? And it's just a service layer. It doesn't even have a homepage necessarily. It's just an API service, right? So you could think, and you'd think that all of these different entities, like this plurality of community, they will all somehow create value signals on that network, right? And you could think that there is perhaps like a higher order incentive, right? Which asks a very broad question, a very hard one, right? It's like, what is the value added to the network by these different communities, for example, right? And you could have, you know, this is where it gets really tricky because, you know, there's a lot of like attack surface on this, but we can start thinking about, you know, maybe rank ordering, right? Communities, maybe using, you know, kind of softer metrics around it versus perhaps having a governance mechanism with a policy, right? That this changes after a certain period. We might have a period where we say, well, the network right now really values growth in the data size, right? But you might have a period later on that says, no, 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 right now, the network is much more concerned about, let's say, reach, which could be calculated through impressions by using the type of service that you're building, you know, Ronan. So like you could think of like a kind of like a fluid policy system that could be established through governance, because it's very clear that there's no, let's say, programmatic, perfect equation of any form of reward distribution over to reach this goal, which is maximizing the value of data. And what would need, and because there's path dependency, you kind of need like this fluid policy system around it. And this is a little bit where my mind is around right now. So yeah, thank you for listening, and I'm really looking forward to diving in with you guys.
I love the dynamic system. I absolutely agree that any incentive mechanism built on such a complex protocol, if we even want to call it a protocol, because it's a very complex system, it's a full economic system, should be dynamic. Got to be able to shift based on the needs of the network as expressed through whatever is used to express them at a given moment in time. And it's determining, like you're saying, what those things, what those expressive attributes are. That is a huge challenge. So yeah, I will challenge a fundamental premise you propose. And I'm not sure how relevant it is to the questions you're necessarily asking. So by all means, just say not relevant. We don't need to go down it. But I don't think it's necessarily correct to assume that people will store scientific data for free. I think the layer is going to need to incentivize it no matter what. It's not, they might store it for free, but I don't think it's safe to assume that.
Yeah, you know, it's not safe, but let's put it this way. I think there's a lot of proof of storage protocols out there, and they all have to solve the cold start problem with early incentives. And so programs like Phil Plus and other types of programs from these storage providers, they would actually naturally incentivize the storage of the super valuable data on this network, right? In terms of archival and things like that. So I think there's a mixture of both a proof of storage networks and system that would have a high interest in subsidizing the storage and pro bono angle. And then there's always, you know, paid storage providers at the end of the day, right? I think so. Like, I think within that group, that's why I'm not like super concerned about storage, as long, and here is like, as long as we don't make it a direct incentive to maximize the amount of data on the network, right?
Yeah, that makes sense.
Yeah, Ronan.
I had a comment, Ellie and I are talking up here about like intrinsic motivations and these kind of usage metrics as value signals. I just wanted to reflect, if you read on the read up on the how science publishers have become kind of these tracking conglomerates, right? They became these like data analytics firms. They basically wanted to reach as deep as possible as they could into the sort of application layer, research lifecycle, everywhere they could to figure out like usage metrics. Like that's what their business is, a large part of it at least. Like buying reference managers, buying social
like
marketing
Elsevier
sites.
and Mendeley.
Buying like all the platforms that host like the download counts, like having all that data, because that's what they're after, like these usage metrics. And I think it's like it can be hugely disruptive and radical if somehow we make that sort of thing, instead of being possible to enclose it like these platforms have done, make it possible for those things to exist in this more open way. But I think it ties into the question of like usage, and the platforms I think have realized something very important is like when someone is using their reference manager, the signals that you get from that, I mean, they're relatively reliable because that thing has a use for that researcher. Like he's using it to store research that he finds interesting. So anything that he stores there, it's not just to game any system. It's just he's doing it intrinsically, basically. So that's kind of what I was, grappling with, sort of this kind of the usage metrics and intrinsic, and like thinking about what signals people are leaving in the context of like how that signal is helping them do something. Like a follow on Twitter is a signal that has some intrinsic value because it's helping that person stay updated on content from someone that they want to hear more about. And it's not just like a thing that they're, just like a +1 on Slack that maybe doesn't have any function, maybe it's just kind of a social signal. So I think there's like, that kind of range of.
Here I think maybe it deserves a little bit more clarification around this concept of incentive, because there's social incentives, right? There's financial incentives, there's personal utility incentives, like what you're describing, bookmarking, right? So perhaps it's worth like being a little bit more expressive, right, around this term, which is otherwise always construed as economic, right?
Right.
Which I think is a powerful one, but a very risky one, because it opens yourself to a huge attack surface. And so they need to be, but I agree. I think that's a good comment, actually, like express the nuance around this term of incentives.
I have a question for you, Ronan, about that. And I'm so glad you brought this up, because a few of us just had a very intense conversation about open metrics, open measures of utility. But one of the, so I'm using this in some of my work outside of here. And one of the problems I've run into is like, I can measure the things that I know I should be measuring now and make those openly accessible to anyone. But what happens when 1,000, so that's my schema, and then 1,000 things get published under that schema, and then all of a sudden we realize we should be measuring another thing. We now need to add, like we have variables A, B, and C already in the 1,000 research objects, let's say, and now we need to add value D to all of them. So we need to go back, so all future objects will have value D as well, and all already published objects need to have value D, so that every object has the same metrics accessible to everyone, so they can build their impact factors. Like how like that seems like an insurmountable challenge. Maybe LLMs can help there.
I mean, you could have a just separate reward for that, item D, right? You can just, so rather than having one entity trying to reward every aspect like of A, B, and C all together, you can have a separate reward for A, B, C, and D individually, and then you can tune them as you choose, right?
Yeah, but the thing is, D is not in 1,000 of the research objects. So if I'm building an incentive layer that's going to incorporate that measure D, I need to somehow get D into all those research objects.
So I'm kind of, it's funny, I'm looking at it kind of on from the opposite perspective, where research objects don't have these things, but more the sort of, I'm looking at the relations between people who are using research and the research object. So like, for example, a bookmark, right? Like someone has added that research to their library, so they bookmark that research. But the bookmark doesn't exist on the research object. It exists in the relation between some researcher and the research object, right? So it seems like, you might be looking at bookmarks as some impact measure, but then you might decide, okay, we need other things besides bookmarks, and then you're adding just a new kind of relation maybe that people have to research. So I don't know. That's kind of how I'm thinking about it. But maybe maybe a different example.
I tend to think that So there's two categories of things. There's like the external markers, right, which can come through a service layer, like what Ronan is building about like a social aggregator, right? Because such a social aggregator allows you to like derive impressions, for example, or things like that, right? And you could say, well, now any application, right, can connect to this API. It's not at the protocol level, it's at the API level, right? We also had a conversation about how we can put it on the protocol, right? But like, that's one path. Another path, of course, is saying, well, every application developer that builds on that network, please, you know, when you implement a stigmergic marker that has value, right, make sure to mirror the data on the network, right? It's another way to say it, right? So so yeah, these are essentially like the two paths. I think a combination of both ultimately is what will be the best. So like my thinking about it is there's no need to like recompute things, right? Or like recreate a chain, because the flow of data, which is mostly external data, by the way, I don't think we should be naive around that, right? It's mostly will come from external sources. These sources will evolve. And I think the services or the application builders that are interested in aggregated metrics like alt metric, you could imagine an alt metric, right? A new alt metric, build out this time of an open social graph. And I think we talked about it, about like showing, you know, like the different sources, where the activity is, where the community is, right? These sorts of markers can be like extremely valuable, right? And I think for that, a lot can be achieved at the service layer, essentially. Yeah, this is always like a interesting conversations around that. Let's see, what else do we have here? Anyone wants to go next, or should I just pick one of these?
I think these are mainly notes on the conversation, so it's not adding that much. One thing that I saw that I think, Shahar, you had added, you had said like Sparkle down when you were talking about when Chris was talking about the Codex index connector. Was there a connection you were making there that you wanted to expand on?
Sure. Yeah, just what like, did you have any thoughts around like the semantic web and you know, Sparkle endpoints and stuff like that?
Yeah, so yeah, I have plenty of thoughts on this. So first of all, like the basic entity in the semantic web, a lot of it's like, you know, kind of a JSON LD structure, right? If you're hardcore, you can go RDF and, you know, all these other things, right? But like the developer friendly version of that is JSON LD. What is IPLD? IPLD is JSON LD, where the only difference is that rather than having a URI, you have a CID, right? So the system essentially is a semantic-like connected graph, right? Semantic web-like connected graph with the variation that it provides tamper-proofness around the data that it's anchoring, right? So that's a little bit that's where these two things kind of connect, because it's like saying, yes, semantic web is great, connected linked data is really important. And we're just doing it a bit differently because we're more opinionated on what constitutes a URI, right? We're not saying it's an HTTP-based URI. We're saying it's a CID-based object, content identifier. This is one part around semantic web. Second part about semantic web, a lot about it is about creating appropriate metadata, right? And what do we mean by metadata? We mean things like controlled vocabulary, ontologies, taxonomies, these types of controlled terms that can be referenced through a permalink that contains the context of these terms, right? So this is when you look at the JSON LD construct, you know, it's not just JSON, because it typically has like add context, you know, Perl. This is, you know, from schema.org, it contains this term, right? This term is scholarly resource that is linking to this thing, right? All of those structures you can recreate with IPLD. Interesting bit here is that we're saying, so when we say about annotations that they can contain semantic payload, we're essentially saying you can signpost, you can add a signpost on any piece, a leaflet of these DAGs, right? And then when you query it, when you query that DAG, you can say retrieve all the metadata linked to these DIDs that I trust not to add garbage on this network, right? Or just give me everything else, right? And then you have the object, the data object, and you have a plurality of metadata attributes, perhaps, right? And from there on, you get a lot of context. And the interesting part about it is because the network is permissionless, anyone can signpost, right? Can start adding these signals on this connected graph and build a reputation around the signals that they do. And you can imagine at the limit, in like an ideal state, right, that this naturally incentivizes, let's say, fair data curators, right, to build a reputation of creating reliable metadata. Why? Because it would then, those metadata would be surfaced on platforms, right? And the platforms, let's say, would say, hey, actually, I really trust this Gopher Foundation when it comes to their fair metadata, but I don't trust like the Pepe Collective when it comes to fair metadata, you know? And they have a different DID signature, so you can very easily filter based on that. So, you know, of course, there's questions about, well, how do you bring value back to the curator and things like that, right? But I think that's a bit out of scope. But essentially, yeah, so that's the connection. So like now you're saying, okay, can we imagine a Sparkle endpoint? Yes, we can. There's a lot of like deeply, you know, people that are deeply in love with semantic web and Sparkle, OL, Turtle, you know, all of these Shackle, you know, all of these things. It's very complicated actually to build like, you know, semantic web systems. But yeah, we could imagine that. It could be like a connector point, and what it would do is rather than spitting out the JSON LD associated with the research object, it could spit out RDF, right? Raw RDF. And there are converters from JSON LD to RDF, right? So that's how it would essentially connect back to that. So yeah, that's my short answer on that.
Nice. That's actually really helpful. The sort of the IPLD in connection to the semantic web.
Oh, it took me so long to figure it out, Ronan. You can't.
That's a very concise way of like, I wasn't able to wrap my head around it.
Me neither. Like the way they wrote the IPLD documentation. It's like, can I make the thing that is like the densest possible thing without any analogy that helps me to grasp it? And that's what they did. I think like, you know, just saying, well, DAG Jose and is like, you know, JSON LD with CIDs would be been a game changer in those early days, you know, trying to grasp it.
Wait, so I have another question about that. So basically, like, if we want to imagine something like Sparkle, like federated search query, stuff like that. So will it will require for curators, for groups to actually like create these like endpoints, right? In order for it to work. So this is like will be part of it.
Yeah, so essentially think about this. This is very early. So this is the DPID page, and you can, you know, resolve for a machine agent. And this was the type of like JSON LD kind of dump you get, right? And you can say, well, I want JSON. Maybe I want, you know, I just want the raw thing. Oops, that's not it. You can say raw. That's the native model. You know, you can have all sorts of different, like here you could have like one that says Sparkle, right? Or RDF, right? So here you could have RDF, right? And it would come out as RDF. Here it's not going to work, but like you can think about it this way, right?
I think there's going to be like probably a bunch of different indexing layers on top that allow you to do different types of queries for different applications. Some may make use of, you know, semantic web components. Others may make use of like something like, you know, like semantic embeddings or like vector databases and that sort of stuff. And I think it's all open for different applications. So, you know, I could see, you know, various different approaches to it. And then one thing to note as well, I do believe that, you know, with the kind of rise in popularity of GraphQL, converting GraphQL to Sparkle and vice versa is actually, I think it's a solved problem. And so, so in that case, you know, we could build to target, you know, one or the other and get pretty good coverage in terms of query capability. And then it's all down to, you know, what's the application that is being used for, and then making sure that, you know, all the data is encoded, you know, for that application.
Yeah, so this is something I haven't added here in services, but Sina is absolutely right. You imagine here a service, which is enriched indexing, right? And it could be all forms of indexing, could be full text semantic indexing, right? And then if you query the service, you can actually run queries that are more powerful than the queries you could run on the network itself, for example, right? So like, and this is tricky because what you want ultimately is fast queryings, right? You don't want to like string find into stuff. You don't want to have stuff that increases in like O complexity and things like that. You want to stay constant, you know, or log of something, right? And like having this high querying performance over a high dimensionality space can get hard. And so like, yeah, so you know, when we say, well, we do provide decentralized indexing capabilities, I do think that there's going to be a need for indexing enrichment services right down the line.
It feels a little bit like the graph network, like the sorry, graph protocol had the indexing, like all those indexing services. I don't know. I'm just kind of not sure. I don't know enough about it, but maybe it's relevant.
Yeah, so like they're essentially trying to create incent. So you know, like blockchain data is a mess, and like you don't want to index it yourself. And the question is like, how do you get truthful indexing? Because if you get it wrong, you can get a big problem, especially if the data is used in an oracle of some sort, then like you're dead. So like, you know, how to solve this problem, and they have a similar problem to solve, right? The problem is like how to create quality indexes, right? That don't have errors and mistakes in them or attacks. So yeah, there's definitely like there's an overlap. There's an overlap. I'm a big fan of them.
And how do you imagine like the incentive layer connected into that? Like how do we reward like these indexes and, you know, curators?
Yeah, I think that's a really hard problem. I would say here, so this is also why I say plurality of incentive layer. This is a way of saying I don't know the solution. And you know what? It's not going to come from me. It's just an acceptance of humility in a sense. But I do say that it should converge towards a set of incentive compatible mechanisms. So like we still need a hyperstructure or a hyperspace that somehow says, okay, everyone, make your incentive layers, add value to the network. But then there's still some sort of way to create a convergence, right? And here is a big question mark because these two statements don't follow. And that's why I say should, right? Because we don't know how. It's a hard problem to create convergence. So yeah, so like I've been taking different stabs at this thing, but I'm not yet done. And I think one of the hard part is a lot of the real usage metrics, they're gameable. Download, views, bots, all of these things can be gamed, right? So we have to be very, very careful. And the other thing is in absence of real world signals of value, what are we left with? We risk devolving into a bad equilibrium, which forms what, you know, Robert Hanson calls a mutual admiration society. We're like, oh yes, Ronan, you're great. Oh, Chris, you're fantastic. Oh, you know, and we're just like in this ivory tower building our thing that doesn't have any external relevance with the rest of the world, which is a tragedy in itself as well. And science is guilty of this a lot, you know, especially journals and communities, you know, mutual admiration societies. So yeah, Ronan?
Yeah, I just was gonna add to that. I think it also relates to this idea of the trust networks or trust graphs that we've been talking about in the last few sessions as a kind of layer of the defense against gaming. So yeah,
Sorry,
similarly like
what was the layer of defense?
Trust graphs or trust networks, like
basically
trust
graphs.
Scientists,
Trust graphs.
each scientist has their own network of peers, like trusted peers.
Yep.
Yeah, but before that, like what my question is where does the value enter the system, right? So, you know, right now scientists, you know, they use like the way that the scientific system works, right? So how can like it seems like the values are like upside down, right? If you know what I mean. Probably you've thought about it a lot. So like how do we flip it in this context, and where does the value comes into the system?
Yeah, I think the value, so like value, so we are fortunate somehow to have some tractable notion of value, right? And that tractable notion is like maximize the value of the data on the network. How do we, and this is there's a lot of problems with this, right? We can go into it, but like we can take it as like a premise, right? How do we create a system such as that the value on the network is maximized over time, right? So one part is technologically solved. These are the so-called like red principles of the fair data principles. These are all the things like having a PID, all of this thing, right? Then there's the blue principles. These are things like community ontologies and control vocabularies, or like having quality metadata and things like that, right? These are more human things, right? That need either, you know, services, external interventions, lengthy forms, and all sorts of hard things, right? You can think about value of a piece of data being a function of two things. The value of the data itself, you could almost say that it's multiplied, right, by a weighting factor, which is the quality of its metadata. Because if you have the most valuable data set in the world and has no metadata whatsoever, it has zero value, right? Because it's impossible to know what it is. It's unprocessable, right? But as the quality of the metadata increases, the value of that data gets expressed more. And there's a point where you have really good metadata and really good data. And the combination of these two things is valuable data, right? So yeah, and you could also think, you know, curation signals, more broadly defined, things like the OSF badges are markers of value, right? They're saying something about the value of something, right? Like, oh, it's computationally reproducible. That's cool. Maybe it's even more valuable, right? Oh, it's been peer reviewed, right? Okay, whatever that is, you know, peer review is a very undefined term, let's say, but like it adds value to the data, right? So it's the combination of the initial value of the data and the quality of the curation systems signals that are accrued on that data, including metadata. And that's pretty tractable, right? We could start doing things with this. We can kind of start, you know, building a model, right? Where things get completely and terribly complicated are all the attack vectors that you can suffer, because defining these attributes is really, really hard to do in a programmatic, hard way, right? So this is where, you know, we think of a more soft metric system, right? We might have like a policy, and the policy could be enacted through governance, and the policy is effective for a certain period of time. And after that period of time, every player in the game knows that the policy ends, and they might get a heads up on what's the next policy. But everything is transparent, and they know what's going to be the next policy, and they know the discussions about the upcoming policy and so on and so forth, so they can adapt, right? And so it's credibly neutral, essentially. So it's not like just fluffy arbitrary. And then the question is like, okay, because like, you know, whatever policy you come up with, it's going to get exploited most likely, right? Because of all the problems we have around the attack vectors, the attack surface, right? So that's also a way to limit exploitation, is to have a finite time period of a policy, right? This is one of these things I've been thinking about, but it's a hard problem. John?
Yeah, the policy approach is actually really interesting. I haven't heard that before. It's an interesting way to approach the I'll just say dynamic part of it.
Yeah, exactly. Let's
but hold on. So because I think I have a perspective that might help with the question of where does value come from, and then also how do we do that hyperstructure thing with a bunch of community, basically value indicators of value that you were trying to describe. Right? I think it helps if we openly recognize that we're not building anything new, that we currently live in the system we're describing right now. Even the policy part, thinking about it, currently exists. The hyperstructure is the US dollar, is the settlement layer of the world, and the world has a bunch of smaller currencies that operate in that system. But ultimately it comes back to the US dollar as a settlement layer based on US military and
okay, Tom, let's
now,
not take this one too far on the
well, if you accept that perspective, then you can recognize that it's not that difficult in the challenge. The challenge is what you were describing, the digitizing of it. But the policy is a good approach to that. And then where does the value come from? How does value get injected to this layer? Well, if the US dollar is currently how value gets injected into the current system, that system is based on debt. What would a new system based on scientific data be? Well, if you just mint a currency, and instead of giving it out to people who create debt, you give it out to people who create data, you've created an entire economic system based on scientific data. You don't need a closed loop sort of thing. This is the glory of cryptocurrency. You're literally printing a currency, and it's grounded in electrical energy as the reason for it to have value. You add stuff on top of that, like scarcity and distribution mechanisms, even to play with that value. It is what cryptocurrency is. So it's not a weird thought experiment. It's literally why it was made. So it's a very this problem has been solved. So it's a matter of how do we direct it in the way we want to direct it.
Yeah.
Just perspective.
Token is the simple part of this, making sure it's attributed in the right way without creating terrible negative externalities is the really challenging part. So yeah, so I'm like really open. If any one of you have like, even after the seminar, if you have any perspective on these things, please feel free to add. I'm going to be working a lot on this vision work over the New Year's. So I'm really curious to gather more feedback around it in general. I'm also happy if any one of you wants to like do some overleaf, have some overleaf fun with me, you know, you're more than welcome.
I just wanted to say something real quick, which is that I think that there's a lot, when you talk about the plurality of mechanisms, I think that that's definitely the way to go, because we have to be able to, at the end of the day, we're dealing with humans. And when one of the most powerful things about cryptocurrencies is that it lets people choose their incentive mechanisms, right? It lets people have a choice in what they're incentivized to do and what other people are incentivized to do. And the beautiful thing about them is if you don't like it, you can leave, right? You like people say like the classic, like, oh, if you don't like this country, you should get out. And you know, it's like that's not really realistic. But you know, in the cryptocurrency world, in the multi-currency economy where you have so many different options and you can literally with a click of a button create your own option, that completely changes how we can organize labor and data and knowledge. And so I just wanted to hit that point on the plurality of incentive mechanisms, because I think that's really critical if we want to really be able to claim that we're creating something new and not just a better version of what came before that might just end up somehow becoming just as bad.
Yeah, because exactly. So you know how it works nowadays. You have for those of you who are still in the dark about this, there's essentially papers that are attested to by scientific journals, and scientific journals are attested to by the Web of Science, which is an indexer, right? So that's the chain, right? If you don't have the attestation from Web of Science, you don't exist. You're not a scientific journal. If you're a paper, but you don't have a stamp of peer review accepted in a journal, you don't exist, right? So like, so it's very monolithic, the current structure, I think. And like, if we really have to think about creating a much more agile system that doesn't fall into equilibriums that consolidate around monopolies. I think that's like a very important property. And yeah, I mean, I'm all for like letting communities, I mean, ultimately, I think that's the way to go. The question is just like, great, so you allow a plurality of incentives layer, fantastic, right? Over time and through trial error, this plurality of incentive layer should converge.
Good. Yeah, ideally.
Yeah. Okay, sounds great on paper, but like, tell me more. Right?
It's really interesting. There's like back in the 90s, and I was looking at this a few months ago. I might come back to it soon. Back in the 90s, there was a lot of really fascinating research in cooperative AI, and it was specifically about like analyzing beehives or flocks of birds. Like how do flocks of birds know that to all fly in this direction, that direction simultaneously? Like it's some kind of collective knowledge that's enabling that. And I think and there's been a lot of AI algorithms, not the ones that we think about in LLMs and stuff, but other things like optimization algorithms, like ant colony optimization, and swarm particle swarm optimization or whatever. They're specifically, they have in mind this idea of taking a natural phenomenon and seeing how bigger structures actually come out of them. Seeing how that behavior is kind of coordinated. And I think that what we'll probably be seeing, because we're LLMs are obviously so massive and getting bigger, and I don't think they're going to go away in the news, but I think that we're going to start seeing other aspects of AI that have been under wraps, not under wraps, but like really overlooked over the past 30, 40 years. Things like, relative to what we're seeing right now. I mean, like optimization algorithms, like the ones I just described, I think they're going to start getting a lot more attention now, because that's the most robust base of knowledge that we have to know how to coordinate, how to potentially coordinate humans. Now, humans are not bees and not flocks, but maybe in the limit we are. Who knows? I have no idea.
And I think a lot of this also is going to be services, right? So there might be humans doing some things on this protocol, and they're probably going to be a lot at the start, but over time it's likely to get professionalized, right? For example, at the start you might have a community that does fair metadata by hand, very inefficient, right? And as a result, the reward is high for doing it because it's hard. But because you have an incentive around it, there's going to be some very clever people that are going to figure out ways to automatize this using LLMs to essentially use the mutual information contained in the research objects and its relationships to determine from the bottom-up perspective to derive these types of AI actionable metadata, right? And so now the cost of verifying data has just been dramatically down, right? And then you could think about, okay, that's great for the protocol. But if the rewards remain the same, extremely high, now you might have a problem because that problem is solved. So that's another one of those reasons why we need to think about this kind of policy layer, which has a window of validity, or I don't know, there's probably a lot of conceptual work to be done around it to like think about how we can make this converge over time, right? I think that's really like a hard problem and a fascinating one as well.
And also like how, I mean, John brought this up briefly, but like if the metrics that we want to reward for change, what do we do? Because we still need to be able, people still were operating under the old metrics, and they didn't work that they should be rewarded for. So how do you balance that? How do you make sure that all that past work is like for example, all of the, in this case, it would be all of the fair metadata that was annotated by hand. How do we make sure that the people who ended up doing that at least get something of their fair share for all of their work, right? And that's a really, really complicated question, right? And I mean, we're gonna start seeing that problem in like bigger social things soon, like when we actually have proper self-driving cars. What happens to all the truck drivers, right, who are getting replaced, right? Like they contributed to this economy, to the system for so long. Are we just going to throw them out on the street, or like how do we actually make sure that because they're being replaced by AI, like how do we make sure that they're not just being thrown away?
Yeah, well, here I mean you're making an argument for against policy layers. In a sense, you're saying it should be a market, right? Because you could imagine that the new service that comes in and says, hey, I do fair metadata, but I do it for 1 cent rather than $1, right? And so like here there starts to be like I think place for markets, right? And because here I think with we have to think very carefully about this policy layer part. It needs to be really agile and not give the impression to people that they're getting rugged on a monthly basis because all the rules change, right?
Exactly.
So this is a tricky part, right? How do we avoid like people building mad systems, optimize for this month's policy if it goes out after a month, right? So like we need to think very, very carefully about how to make very extremely clear rules around it. With appropriate periods of heads up and an appropriate degree of like, feeling that your efforts will not go for nothing at the end of the day, right? So like this is I think this is where it really needs a lot of thought, because I think it's an easy way, it's an easy cop out in a sense. It's like, okay, we can't figure it out. Let's do a fluid policy layer, right? It's like, great. Well, in principles, it can solve it, but the devil is in the detail of how it's going to be orchestrated.
Yeah, that's a really good point. I mean, and there are some like heuristics you can use, like rewarding over, like we're going to set this aside for at least 6 months or whatever, and that can alleviate some of it. But that's not really a good answer. That's like a a greedy policy algorithm where that gets like half of the optimal, where we know that we can do a lot better. You're right. Like we have to. It's a very careful. Like how do you? Because there's a lot of human. It's not just technological. There's a lot of like human motivations involved in how you would do this.
Yeah, and imagine you might have like 5, 10 starting communities building on the network, doing things, and what you might see over time is that they're actually really hard to judge who has added most value on the network according to a certain policy, because the policy in itself could have soft and hard metrics linked to it. So how do you evaluate soft metrics, and how do you avoid conflict around that, right? How do you also account for the fact that there's luck involved, right?
Yeah.
So I think, there's a lot of like little very, very spiky questions around that need to be thought through deeply. You could imagine, you might have a certain month which says, hey, right now the policy is to get as much DIDs minted from ORCID keys, because that means onboarding, right?
Mm-hmm.
So it's a hard one to fake, because we might have a cutoff point. All the new ORCIDs are invalid, right? Just work with existing people. There's 7 million of active people there, right? Do your best, right? That's one we can work with. But you can imagine that, well, okay, if they all get a DID and they just post some random stuff or something like that, it's not as useful as it could be, right? So like maybe the next month is like, well, this month we're really optimizing for a tested research object that have these attestations, right? Something like that. And so, yeah, you could think that there's a lot of like, policy flexibility that's required to make this thing converge over time, right?
Yeah.
Yeah, I have a question about that. So like in the Figma, so you have like the CODEX incentive community level. So right, this is basically kind of tells you how does the data contributors are going to get rewarded, and then you have like the service layer, like indexers, and someone opened like a Sparkle endpoint or something like that, and maybe he charges something, like they charge something for you to query the endpoint, and then the reward, like the service will need to reward the data contributors that whatever sort of metric the CODEX incentive community level set, right? This is like there's like 2 levels of like the service level that kind of incentivizes curation, maybe, or maybe it's rather centralized.
Yeah, so you could think here, for example,
AI that does that.
Yeah, so like think about it this way, right? You have different agents that operate at different levels within these layers of abstractions, right? And they all contribute value in their own way, right? This loose definition we had of it. You can imagine a service provider that actually provides tremendous value, that the network just decides this is great. We're going to reward that, right? Like this social media aggregation is fantastic stuff, we love it. Here's a batch. This policy is running for X, and it's just going to keep running to like say thank you. This is great, super valuable, right? And this indexing layer does not need to have its own incentive system, right? It can have it, right? It can say, well, I'm really interested in creating a bridge for machine actionability. So like I'm interested in fair data. So every like research objects with attestations with this and that and those provinces that I whitelist are eligible to my rewards, right? And these rewards are completely independent from the policy level rewards, right?
Yeah.
Same with a community, right? You might have a community that does open peer review over preprints, right? And that community engages in that, and you can see it. You see the stats, you see peer reviews submitted, preprints linked, all that stuff, right? And it's actually really valuable for network. But they have their own incentive system as well, right? They really reward their community members for adding valuable peer reviews, right? And but this again is completely independent from the policy layer, which says we actually, we have policies, through some mechanisms of governance, and we enact these policies so that it represents the overall interest of the network, right? So this is a little bit the way to think about it, is that this any actor within that hierarchy can create their own incentive layer to signal what they value, right? It's a way for them to signal what they value first and foremost, right? And it's separate from this policy layer, right?
Yeah, so like in the roadmap of DeSci Labs, the focus right now is on the CODEX, the DeSci CODEX.
Yeah, so we have two focuses. We have the CODEX layer,
Mhm.
and we have the application that we're building out. It's one thing to just offer developer toolings, but people need to see and interact with like really cool applications, right? So
yeah, definitely.
This is our balance of efforts between protocol development and application development. And we also think about this application as a way to let communities. Let me just go to let communities essentially build out their own applications. So if you go on a DeSci node right now, you have access to like a data drive that lets you navigate all the components in the DAG. You can look at the data, you can look at the code, you can essentially import any type of artifacts and make them and render them, in the interface. You can connect figures with Jupyter notebooks. You can essentially like create these like rich dynamic publications that contain all of these research artifacts, right? And that's kind of like the base primitive is to say, here's a box, and this box will build a tree, right? And that's this research object.
Because I have to head out, but this has been amazing. It's a great discussion. We should definitely continue. And yeah, I'll see you all soon.
Thanks, Levy.
Yeah,
see you.
Next conversation. Bye.
And so here, the only application we have is the DeSci nodes application. And also, we'll have like the ability to explore and, view different works and things like that. This is all work in progress, by the way. And the idea here is you might be able to add your own applications in the Docker, right? And so now this is a fully open source app. And now you could think about people that they're coming in and they're like, I don't want to rebuild this from scratch. This is a complicated thing, right? All of this ability to store the data, to make it fast, responsive, all of those like state-of-the-art web tech things. I don't want to deal with that. Give me just a space where I can add my own app that interacts with this data in some way or provides value, right? So you could think also that you can think about as this platform being like a base application that any community can like appropriate and add their own, plugins or sub applications that would live in this bar on the side, right? So yeah, that's a way, we've been thinking about this, and like and we're just like building out just the basic bones around it, right? This how this connects to the protocol, the anchored hash, like being able to diff the versions, having the ability to see all the changes that have been done over time, because there's all this, transparent record of how change happened. And so you could think about that as a new way to like create, scientific communication systems and browsing interfaces and ways to publish your research that lets you, publish code, data, any kind of like components, right?
Awesome. Yeah. It looks great.
Yeah, that's the one of the big focus. I would say is like 75% is getting a good app.
Yeah, definitely. This is also like our kind of um vision of how are we supposed to work, like in common sense makers, right? So at the end, we didn't get to that point, but the idea was, yeah, okay, we need to build, like, first of all, we need to be like to give value, right, to people everyday use. People can get value immediately, and then right. So then you create the protocol, right? You create the
Yep. Yeah. First you deliver value at the application level, and then you abstract away the things that deliver value to make them generalizable. Yeah. Yeah, that's the
Yeah.
approach here as well. But here you could imagine having your app, right, in the Docker, and you click and you see all the social media activities related to this paper, right?
Yeah.
Every service. That's fucking cool, man, right?
Yeah, definitely.
So this is a way of like, so you guys don't need to like invest hundreds of thousands in like building out, like these complicated applications that are, it's like Kubernetes, like all the Terraform, all the like, there's a lot of things that go into making like fast, responsive, scalable web apps that are really, really hard. And I think if we can provide like a common platform, right, that abstracts away a lot of the complexities around it, that you can redeploy if you want, I think that can really help lower the bar for creating valuable applications. Another thing we're planning to do here is, conflict-free replicated data types. That's almost live. That means we'll have multiplayer. You'll have like, just like Figma, you'll be able to see who's on the document, right? Who's working on the drive, who's interacting with that research, right? And so you can think about this now. Now you have multiplayer and multi-tenancy enabled, and all the applications on it can benefit from that without having to actually implement it themselves, because it's really hard, right? So if we can like create a large surface of inheritance of interesting properties that people don't have to deal with, and like reinventing the wheel, that would be like a huge win,
Yeah, no, definitely. Yeah, and I really love this idea that, instead of having like a social media platform, right, you need to just have a social layer on the internet, right? You need to meet people where they are, right? You don't have to go to the same, like web application and yeah.
Exactly. Yeah, and we think like this was like the most high value, high leverage starting point, is just this idea of like, hey, with this structure, you can publish everything. You can publish your data, you can publish your code, you can link external links. You can just create this like container that gives you PIDs for every parts that's published into that, right? That have deterministic resolution, which is an attribute no other PID system has, right? Which is kind of cool. So like this IPNB notebook, this path up here, this has deterministic resolution, and I can import it just by copy pasting these two lines of codes, right? So here I can fetch this notebook, I can fetch this data just by running this command, these commands in Python, right?
And everything just in the network, everything is public. Like if you have the address, you can access it.
Yeah, so like if you have the CID, so the CID is in the app, you can access it definitely. So in the future, we're also building out the private data part, but you can find here, you can essentially find the CID associated with this object here, right? Which you can resolve over IPFS, any gateway.
Yeah, but because I'm trying to imagine like how researchers, would want to use this. So for example, so my wife is doing her postdoc in a UPenn right now, and she's really happy. There's a lot of researchers, and they all kind of, all the time, get together, write new papers, stuff like that. And I have tons of data that I collected, like in Uganda, about this and that. I'm not doing it. I'm not doing with it anything. I can just send you the data, right? So I can imagine. Okay, so we have the system, we have it like already there. You know, you can just with a click, you know, just expose the data to whoever you want to. But just, you know, I think like we want to strive to a place, you know, the open science, right? But like in order for, you know, like reeling in people kind of, I think that they would rather have the option to keep it private.
Absolutely, man. So like this is a high priority on our roadmap. And so essentially you can think about these research objects, they have a root here. And so there's going to be a public and a private root. So when you go down all the way down the drive, you have essentially a public and private root. And so when you publish the object, everything that you mark as private goes in the private root, and it's not on the open network. Everything that's in the public root is on the open network. So then you have the ability to decide what you share with the world, right? And yeah, this is the most requested feature. So yeah.
Okay. And is it like decentralized? Is it
so essentially anyone can like mirror the data on the network. So yeah, so it enables like full decentralization over the network and over the data layer, right?
Yeah. And for the like the privacy, like is it connected to any?
Yeah, so like the private data, there's two ways of doing it. There's the level 1 way, which we're doing right now, which is we have two IPFS network. A private network, it's not connected to anything, and a public network connected to the public IPFS. An interesting property out of this is you still get a root CID over your private data, but nobody can access it. However, you can prove at any point in time in the future that you knew this information in advance because you have the root. So it has interesting properties for pre-registration, for IP, for things like that. You can prove that you knew something ahead of time. So you have a form of proof of knowledge baked into it. That's like level 1. Level 2 is saying, well, you know what would be better is if the private IPFS network doesn't just live on DeSci Labs internal servers, right? It would be nicer if we had a encryption scheme that let you post encrypted data over the network that then uses multi-party computation to reconstruct that network from the key that is whitelisted as allowed to access that network, that data. Yeah, so that's level 2. As you can imagine, level 2 is much harder to do it well, right? But we will get there eventually. In the meantime, we're just going to go, you know, this is our tech tree, right? Private IPFS root, public, encrypted, MPC. And for this, we might use LIT protocol or something else, you know. It's open question here on the side. But yeah,
no, it totally makes sense, right? I think yeah, until you really need it, so just make it make it so it could get there, but you know, it adds a lot of complexity into it.
Yeah, it's a matter of prioritization because all of this is doable and super exciting to do. The question is just what you know gets users as fast as possible to use the system and these things, you know. Good old startup problems to have.
Yeah.